Well, there is an important note that we forgot to discuss here. We have this time used the MOSFET from the manufacturer. For example, SI7336ADP. If I right click this one, you see this is the MOSFET name. This is a manufacturer name. It is a N channel one. It has a maximum voltage handling capacity across drain and source. It is about 30 volt. When it is turned on, it has the on resistance, uh, which is given to be about uh, 0.0024 ohm. So it's just 2.4 milliohm. So it's a highly conductive channel there. And then there is a charge on the gate in coulombs. So it's about 36 nanocoulomb. And that's so. If you pick MOSFET and you see in the blue line, these are the parameters that I just explained, and then comes the SPICE model with the information. Let me highlight here, right here. Yeah. So here dot model, then name of the transistor, then you have this gate resistance RG, drain resistance, RS is the source resistance, and what is this M triode? I don't know what that. Lambda is the channel length modulation parameter, which is 0.01. Then threshold VTO is 2.9 volt of this transistor. And then you have this Kp is the process parameter, which is 280. Then CGD max, that's the capacitance between gate and drain, 16 nano. Then CGD minimum 200, that is capacitance between gate and drain, 200 pico. Area A equal to 1.5. And then we have this CGS, capacitance between gate and source, 5.2 nanometer, 4 nanofarad actually. And then CJO, junction capacitance, 3N. Then you have M is equal to 0.5. Okay, and then you have LS RB, manufacturing name Siliconics. VDS is 30 volt, R on is 2.4 milliohm, and the charge on the capacitor. So this is the complete, this is the charge on the gate, 36 nanocoulomb. So it's a complete SPICE model. So now we are trying to simulate the temperature behavior of the generated V reference, V out, by connecting or shorting the drain and the gate together. And initially we will perform the operating point analysis on this manufactured part of the MOSFET with the supply voltage of 5 volt. Resistor R1 is taking the current, drawing the current into the circuit and feeding it to the MOSFET. Then as you can see that, now let me, here is the temperature response. You see that the generated voltage, which is at room temperature right here, is about 2.59 volts. And then if you make a sweep from -40 to 120 degrees centigrade, it has variations about from 2.63 volt to 2.51 volt. So that's the generated reference of the MOSFET behaves. So in the previous model, we just use another MOSFET, not the manufacturer part, but it was the four terminal MOSFET from the SPICE library. The behavior of that MOSFET, the output voltage was varying positively with respect to temperature, and this behavior is having the temperature, negative temperature coefficient. So just to have a correction of that error. Okay, so let's connect the dot operating analysis before. Just disable this analysis initially, let's say dot step. So I would just do like this. Look at this, with this it is disabled. Now I click simulate and this file is generated, that is giving me the currents and the voltages into the circuit. So we see that the voltage at node 001 is 5 volt, which is this net. Then 2.5 volt is what I generated. I am letting the current flowing through this transistor, which generates the VGS, which is output voltage of 2.58 volt. current is 2.4 milliamperes. That is the drain current. Essentially, the gate current is 0. You see that, but it shows me the gate current here. You see, so in ideal MOSFET, you will have Ig equal to 0. But look at this value. The gate current is about 1 nanoampere, pretty small as compared to 2.4 milliampere of drain current, but still it is there. And the source current will be then gate current plus the drain current. And negative sign indicates the opposite polarity, opposite direction of flow. The drain current is incoming, source current is outgoing, and also the gate current is showing uh, incoming. Okay, so incoming current right here. All right, so with that said, we can run the uh, temperature analysis again by enabling this one. Just put a dot now, and we sweep the temperature and we plot this voltage like this. And this is how you get this value. Okay, so hope you like this video, and just compare this in the previous session video, so you will get the behavior of the MOSFETs.